All right, hello people watching this video. I'm going to go through one example on your homework assignment, 10-3, and then we've got two more examples to do on the notes, example 3 and example 4, and then we're done. So 10-3, polar form is what it wants, okay? What form is number 3 in right now? Do you remember? What is this form?
It is in currently rectangular form.
It is currently in rectangular form, okay? Now, it does not have like two parts to it like all the other ones do, like 6 minus 8i. This is just negative 2i. So if it helps you to think about it, you can make it 0 minus 2i, right? Like it's missing the 0 part, okay? If I convert it to component form, which is what we talked about the other day, what would its component form be?
0.
Yeah, in the triangular brackets would be
2.
0, negative 2. That's component form, okay? All right? They want polar form, which is this thing. R cosine of theta, I sine of theta. So all we have to do is find R, and all we have to do is find theta. Now, this looks a little confusing because it doesn't have two pieces to it, okay? So let's map out where negative 2i would be, or 0, negative 2i. So 0 to the left, negative 2i down would literally be this dot right here, right? And this is where it gets kind of confusing because this is actually easier than any of the other problems, okay? So what I'm doing is I'm trying to find the R value or the absolute value, okay? R equals the absolute value or the magnitude, okay? Now normally I have like a triangle going on and I'm trying to find the length here, right? But this one doesn't have a triangle. It's just like literally like this right here. Okay, so what's the magnitude?
Negative 2.
It would actually just be 2 because magnitude is distance and it's only going to be like positive, so our R value would just be 2. Now, you can see that from the component form. We know that we take like a squared, b squared, c squared, so like my a would be 0 squared plus negative 2 squared, and I take the square root of that, which ends up being 2, right? So like that checks out, okay? My R value is 2 because it's only 2 units. So I have 2, and then I have cosine of theta plus I sine of theta. And I have to figure out what theta is, so I'm going to get rid of him. I gotta plug numbers in for theta. I gotta figure out what the angle is, okay?
270.
Now the angle, we did tangent before, right? Like to figure out what the angle is, because we're going from here around to here, and we'd have to do tangent to figure out what that is, and then figure out that quadrant. But if he's already down here, like on there, I heard some of you say it. What's that angle? 270,
14.
right? 270 degrees and 270 degrees, okay? Now, this is polar form. That's done, right? Like, we didn't even hardly have to do any of the tangent stuff and any of the hard stuff, okay? Now, do you remember how to switch back from him to, like, these two forms? How do I switch, if they give me polar form? What? Multiply it through, right? What is 2 times cosine of 270? It better be 0. What's 2 times sine of 270? It better be negative 2.
Negative 2.
Right? That's how you switch back and forth between the two. You just use your calculator. Now, you have to make sure that you're in degrees to do that, but this is the answer to polar form, and then you can check it, right? Okay, number 6 is going to be that same way. I'm not going to do this one for you, but this is like 3 plus 0i, right?
So, would it be 360 or
You
0?
can either put 0 or 360. I don't care. Okay, did you hear Luke's question just now? 3 plus 0i is going to be over here, 1, 2, 3, okay? So, if I do that, fine, we'll just do it. What is the R going to be?
3.
3, right? Like 3 squared, 0 squared, square root of that is 3. It's just 3 units, okay? And then I have 3 cosine of, what's the angle going to be? It's either 0 degrees or you could do 360 degrees. It doesn't matter because they're the same. So we can just put 0 degrees plus I sine of 0 degrees. Does that make sense? Okay, so those ones where it only has one piece to it, that makes it kind of nice because I don't even have to do any tangents or Pythagorean theorem stuff. It's just like count it over and figure out what the angle is, right? Questions about that? Is that icky? What?
What's the I?
The I is like just the y coordinate. I don't know. It's like just the part. It's just the part of the complex number. So like here, like this I is the same I as what's in rectangular form. It's just how you map a complex number. I don't know. Whatever. Okay? They use that stuff like when they're talking about like circuits, I think. Like, I don't know if you do like I is in Mr. Moose class where you talk about like joules and things like that or whatever where you're adding circuits together, but a lot of those things are like in A plus BI form when you're adding like two charges of circuits together. Anyway, whatever. Okay? That was 3 and 6. All right, go back to the homework, or go back to the notes, and we're going to talk about what happens when you multiply and what happens when you divide. Two things that are in polar form. Got it? Ready? Blink and you miss it. This is like super, super easy. Polar form. Again, polar form is R cosine of theta plus I times sine of theta. Okay? And they're saying Z1, Z2. Which means we're multiplying Z1 and Z2 together. Like they're right next to each other, that means multiply. Okay, look at the notation they use when we're dividing. Z1 over Z2. Do you see how that's division? Okay, so division versus multiplication. Z1, Z2 is just saying take Z1 times Z2.
Teachers, the lifetime sports kids are just getting back. Please admit them into class.
Z1 times Z2. Okay, so the R value for Z1 was 2. The R value for Z2 is 3. You see that? And then the angle for Z1 was 5 pi over 6, and the angle for Z2 is 7 pi over 4. Got it? Here is how you multiply. Blink and you miss it. This is easy. Okay? When you are multiplying, so to multiply, here's how you multiply. You take R times R in the front. Then you take cosine of theta. I'm going to say theta 1 plus theta 2. Multiply means add, kind of like in log world. You remember?
Couldn't you just say R squared? Or is that R1 times R2?
R1 times R2, yes. R1 times R2. Yep. I should specify that. And then theta 1 plus theta 2, right? So all you're doing when you're multiplying is I take 2 times 3. And that is 6 out in front, okay? Then I have cosine of theta plus I sine of theta, okay? This is when we are multiplying two polar forms together, okay? So I'm going to take my first angle, which was theta 1, is 5 pi over 6. And when you're multiplying, you're actually adding these angles together. I'm adding to that 7 pi over 4. Got it? Okay, now, don't give me a decimal. We want to make sure that we have it like nice and good. And we want to find a common denominator.
12.
12. So if I change this to 12, this has to be changed to 10 pi over 12. Okay? If I change this to 12, this has to be 21. What is 10 pi over 12 plus 21 pi over 12?
31 pi over 12.
31 pi over 12. 31 pi over 12. And you don't reduce. Just leave it as 31 pi over 12.
Plug it in for both sides.
And you plug in for both of them, right? That is your polar form. So to get polar form, you multiply to get this number out in front, and then you just add the angles together, and that is your new polar form as a result when you are multiplying.
Easy.
Got it? Easy? You can probably guess what you're doing in the next one. The next one is division. You are dividing, okay? So when you are dividing,
Does it matter which one?
division. Now, yes, it does. The way that they have them listed here is the way that you have to divide them. So Z1 goes on top, Z2 does go on the bottom, right? Okay? So when you're dividing, you literally take R1 and divide by R2 instead of R1 times R2. Then your cosine of theta plus I sine of theta. What do you think you're going to do with those
Minus.
thetas? You're going to subtract. Okay, which one minus which one?
Theta of 1 minus
Whichever
theta of
one
2.
you say the top one is. So if they put Z1 on the top, that means pi over 3 has to be subtracting the pi over 4, right? Do you see how that works? Pi over 3 minus pi over 4. Okay, now let's go ahead and do that. What is pi? Well, okay, so what's my R1 divided by R2? What's the number out front?
5.
5, right? 10 divided by 2 is 5. Okay, and then I have cosine of theta plus I sine of theta. Okay, we're going to do pi over 3 minus pi over 4. I need a common denominator. 12. Okay, so if this is 12, this would be 4 pi over 12 minus 3 pi over 12 as my common
Pi over
denominator.
12.
That would just be 1 pi over 12. So pi over 12 goes here, and pi over 12 goes here. And that is the result that I get when I am dividing those two vectors in polar form, right? I'm taking those two guys and dividing them. Multiplication, division. Questions about that? That is the entire back page. Shall we go look at the entire back page? Sure. Okay, now, one more thing. Let's do one of these together because they do have an extra set of instructions on 13 through 17. So here we go. Let's do the first one together. It says multiply or that should say or divide instead of divide. So multiply or divide the following. Express your answer in both rectangular form and in polar form. Okay? So we're gonna do the polar form first, and this is a multiply one, okay? So when I'm multiplying, put that away. When you're multiplying, what's your R out in front gonna be? What's your number out in front there gonna be?
12.
12. So 4 times 3 is gonna be 12, okay? Then I'm going to do what to the 5 pi over 12 and the pi over 12?
Add it.
I'm gonna add
Together.
those, right? Okay, so what's 5 pi over 12 plus another pi over 12?
Pi over 2.
Is 6 pi over 12, which is pi over 2. So cosine of pi over 2 plus I sine of pi over 2. Got that? Do you see how we got that?
Yep.
This is polar form. That's one part of the answer. Now they want me to switch it to rectangular form. And just as a reminder, rectangular is something plus something I. Or it could be minus something I. Right, so I'm going to erase my plus
So
sign.
do you have to be in radians to do this?
Yes, you do. So when you're going from this
That's
guy,
rather bothersome.
when you're going from this guy to rectangular form, I take 12 times cosine of pi over 2. But pi over 2 is not degrees, true? So this is how I know I have to be in radians. So cosine of pi over 2 times 12, somebody tell me what that is. 12. Is it 12 exactly? No, it's 0. It's 0. It's 0. Yes, true? Because cosine of pi over 2 is 0. And 12 times 0 is 0.
12 times cosine of...
Sine of pi over 2 is 1, right?
It's 0.
Y coordinate at pi over 2 is 1. So this is
0.
0 plus
Plus
12i. Or just 12i. I don't care how you write it. 0 plus 12i or just 12i. That would be the rectangular form. Got it? Does that make sense?
Do you realize...
But when your angles are in, and these are all in radians. So 14 is a radian. These are radians. These are radians. So you need to be in radians when you convert to rectangular form. Got it? So there is that. Questions about that? Multiplying, dividing. It's like really not that terribly hard, right? Okay? There you go. That's all I have. Okay? All right, on Monday, we'll do 10-5, because, Tuesday, I mean, because we don't have school on Monday. Tuesday, we'll do 10-5 because we skipped 10-4, so we'll do 10-5 on Tuesday, Wednesday, and then 10-6 on Thursday, Friday, or whatever, however that works, okay? Maybe I'll be with you, maybe not. If I'm not, I have them all recorded, so you're good to go. Okay? Yeah, I know. It's crazy.
No, you can't leave us.
Okay? You'll be fine. You'll be fine. You'll be just fine. Okay? But you gotta pay attention to the videos I send. Goodbye, people watching this.